assignment is going to deal with radicals and fractional exponents. And for reference today, we're using the Intermediate Algebra 1 step, which is a supplement to the regular textbook of the course here at SCC. And it can be bought in the bookstore for about $3 or $4, I think, if you need to have one. Now, to begin with radicals, I think everyone in intermediate algebra realizes that the square root of 144 is what? 12? Now, how would you know that if you didn't already know it? How would you know to check that answer? Because 12 squared is 144. Or if you had the square root of 25, the square root of 25 would be 5. And you can always check that because if you take that 5 and square it, you get 25. Okay? What if somebody tries to sneak a fast one over on you and ask you for the square root of negative 25? I don't think this is in the assignment yet, but I think it might be worth mentioning. Somebody says, square root of negative 25. You want to take a guess at it? Take a guess of negative 5. Negative 5. Does that look good? Sure. Well, how would you check that to make sure that it really is? You'd have to take this answer right here, take this answer, negative 5, and square the negative 5, and see if you get negative 25. Do you get negative 25? No. So in other words, that doesn't work. Now think about this. If you had the square root of any negative number, a square root of any negative number, and if you square, if you said the answer is negative and you square it, you're going to get a positive. If you say it's equal to a positive and square it, you're going to get a positive. You can't get a negative number. There is no real number that you can square that will get you negative 25. In other words, there is no number that will work. Now try it with your calculator. If you haven't done this yet, take your calculator and do the square root of 25. Now that's easy, isn't it? All you have to do is just take your calculator and hit the square root button, and bingo, there's the answer. The square root of 25 is 5, right? Everybody get that? What if you gave your calculator negative 25? First of all, do you know how to give your calculator a negative 25? Start probably with a 25 on your calculator. 25 on the calculator. And then do the plus or minus key. Is there a button on your calculator that says plus or minus? Right, hit that plus or minus, and you see what it does? It changes it to negative 25, doesn't it? Now hit that plus or minus key again, and what does it do?
Takes it away.
Takes it away. It goes back to 25. Now hit it again. You see what it does? That plus or minus key just changes the sign of the number in the calculator, in the display of the calculator. So if you were to give it 25 and then plus or minus key, it's going to give you negative 25 in the calculator. Okay, now hit the square root button and see what you get. Now hit the square root button, which looks like that. The square root button, what do you get? Error. The calculator says error because you can't take a square root of a negative number. You can't take the square root of a negative number in the real numbers. Okay? More on that later. Okay? Now, what if I said cube root? Does everyone know how to do a cube root of a number? Like a cube root of 27. I'm picking nice, easy numbers. I hope you appreciate that. I'm not just making up numbers at random. What's the cube root of 27? You'd probably say 3. 3. Now, how would you check that to make sure? You'd have to take 3 and cube it. 3 raised to the third power would be 27. Right? 27, not 9, no. All right. So 3 to the third power, don't say 9. 3 to the third power is 27. Okay? And that's the check that the answer is indeed 3. Okay? Now what if I said the cube root of 64? Then what would you say? 4. And what if I said the cube root of 125? What would you say?
5.
5. And you'll notice I'm not asking you hard problems, am I? A hard one would be something like, what if I said, find the cube root of 72? The cube root of 72. You don't know that right offhand, do you? There is no no whole number that you can cube and get 72. So what we'd have to do would be simplify it by breaking it down into product of a perfect cube times some other number. We're going to get to that next. So hang on to that thought. We'll come back to this idea. In the meantime, do you know how to take, like, let's say, do you know how to do the cube root of 27 with the calculator? Let's try it with a calculator. If you have on your calculator this button that says y to the x power, you have that button on your calculator? Look right above that button. There's probably written in a different color on the calculator somewhere. It probably says the x root of y. Do you have such a thing? Or maybe it says y to the 1 over x. Sometimes the calculator says y to the 1 over x. Sometimes it says the x root of y. Sometimes it doesn't say anything. And sometimes it even works, even if it doesn't say anything. It's amazing. Now, in order to access that key, we'll have to use the second function key. You see, if you just press this button, y to the x power, it's going to raise to the power. But if you want to take a root, what you will have to do is in the top left-hand corner of your calculator is something called second function or alternate or shift. Or what else might it say? Does anyone else have anything? Inverse, INV? Whatever it is, that's what you have to do. So we'll start with 27 in the calculator. Put 27 in the calculator, and then press that button, whatever it is, the shift key. Or maybe it says second function key. Or maybe it says inverse key. Whatever that is. Hit that button, and then hit the y to the x power. In other words, you're not taking y to the x, you're taking the x root of y. And usually this will be in the same color as this is. I messed up in my colors there, didn't I? I should have done this in the same color as the shift key, because it's usually going to be color-coded. So anytime you want to get this function, you use the shift key first, and then do the equals. I'm sorry, no, you don't do equals. Now, after you do the shift key, you have to tell it what root to take. So you'll have to tell it what root to take, and the root we're taking here is going to be what? The 3, because we're taking the cube root. So give it the root, which is 3 for cube root, and then do the equals, and that should give you the correct answer. Does it give you 3, I hope? It does?
Yeah.
Okay, good. All right. Now, let's try another number. Like 64. Do the cube root of 64. The cube root of 64. We start off with what number? 64. And then we're going to do what? Shift x to the y or y to the x button, which is going to generate this x root of y. And then what root? 3. Give it a 3, because we're doing a cube root. And then equals, and what does it give you for an answer? 4. Okay? I hope that worked for you. Okay? All right, good. Now, what if I wanted to take a 5th root? All right, what if I took the, let me do a 4th root. The 4th root, a good number to take a 4th root of would be 16. The 4th root of 16. So what I'd want to do first here is I'd want to do 16 is the base number. Enter the base number in the calculator, and then do shift, and then do x to the y power. Now, what root are we doing? 4th root, okay? And then equals, and then what do we get for an answer? 2. Okay, so the answer would be 2. Any question on that? How would you do that without a calculator? You'd have to know something. First, to do the 4th root of 16, you would have to know that 2 to the 4th power is 16. And then the answer would be 2 in your head. Okay? 2. All right? What if I asked you to do the 5th root, let's say the 5th root of 32? Can you do the 5th root of 32? 2. In your head, you do it 2. How did you know it's 2? Because you know that 2 to the 5th power is 32, so therefore the answer is 2. How would you do it with a calculator? Starting out with 32, we'd do shift or inverse, y to the x, and then instead of 3, what are we going to give it? 5. 5, right? And then equals, and you'll get 2. Okay? So that's how you raise to a power. This is how you take a root of a power, of a number. How you take a root of a number with the calculator. And I always like to do this with problems that I already know the answer to. Learn how to use the calculator with examples that you already know, and then when you get to one you don't know, you'll be able to do it. Now there's one more concept in basic radical that I need to talk about, and that is, what if you had the square root of x to the 4th power? What would it be? X squared? What if I said the square root of x to the 10th power? Do you remember what we do with the square root of x to the 10th? Any good ideas? X to the 5th? Now, anybody skeptical of that? Say, I don't see how you got that. What would you have to do to check it? Remember, we take this answer, x to the 5th, and we square it. Because this is a square root, we're going to square it, and that would give you what when you multiply exponents? X to the 10th. All right, now that brings up a thought. If when you raise a power to a power, you multiply exponents, then what do we do when we do a root? You divide exponents, okay? Now let's go to a cube root. What about the cube root of x to the 12th? Any ideas? X to the 4th. And how would you check that to make sure? X to the 4th raised to the 3rd power would be x to the 12th, right? And that checks. So the answer is x to the 4th, okay? So you divide exponents, all right? Let me see if I can give you a problem or two, or maybe I'll make up one. I don't see a problem I like there, so let me make up a problem. This is going to be a perfect cube. What if I ask for 125 x to the 6th, y to the 9th, z to the 21st? What's the cube root of all of this? First of all, what's the cube root of 125? 5. What's the cube root of x to the 6th?
X squared.
X squared. In other words, if you're dealing with exponents, you divide the exponents. And then y to the 3rd, z to the 7th. Z to the 7th. Any questions on that? Okay? Good. All right. Now, suppose we have problems that don't come out even. Like suppose instead of the square root of 100, which everybody knows the square root of 100, right? What would that be, 10? Then what's the square root of 98? Well, you could say it's almost 10. With a calculator, you can get a decimal value that's an approximation for the square root of 98. But what I want to do, I want to simplify the radical. That means I want to find some perfect square that goes into 98. Let's write this as two separate square roots. I don't want to get the decimal value, I want to get the exact value, but I want to simplify what's in the radical. This is called simplest radical form. What perfect square goes into 98? 49, all right? 49 times 2. So the square root of 49, everybody in here can do the square root of 49, can't they? Everybody in here can do the square root of 49, which would be 7. And nobody in here can give the exact value of the square root of 2. Not even Barry and I can give you the exact value of the square root of 2, right? It's got to be a rounded off value if you give the decimal value. So we just leave it in a square root form. Just leave it as the square root of 2. So the simplified answer would be 7 times the square root of 2. Okay? Now, what if we had something like the cube root of oh, what's a good number? Cube root of 72. I think I mentioned that earlier. The cube root of 72. Before I do that, let's do the square root of 72. The square root of 72. What are we looking for? We're looking for a perfect square that divides into 72. Can you think of a perfect square?
36.
I hear two answers, and this is normal. I hear 9 and I hear 36. If you said 9, let's split this into two separate square roots and put the perfect squares up front. I heard somebody say 9, so let's put 9 up front. And then what would be the leftover number? If you put 9 up front, the other number would be 8. Okay? Now what about 8? Are there any perfect squares that are still factors of 8?
Yeah.
In other words,
2.
2 times, let's see, 8 would be like 4 times 2. So let's break that down into 4 times 2. And you see, this 4 is a perfect square. So what should I do with that perfect square? I should put it over here with this other perfect square, don't you think? In other words, I don't want the 4 because it's a perfect square. I want the 2 in the radical alone. And I will bring the 4 back over here. Now, 9 times 4 is what? 36, which is the other number I heard some of you saying. Now, it would have been better if you look at 72 and just get 36 right up front. Get 36, put 36 times 2. That would be probably the best way to do this. 36 times 2, the square root of 36 would be 6. And then the square root of 2, we'll just leave it as the square root of 2. So the answer is 6 times the square root of 2. Okay? Now, if I'm talking about the cube root of 72, now what I want to do is get 2 separate cube roots and have the first one to be where I put all the perfect cubes. And by the way, before I ever start this problem, when I first said cube root, what numbers should have flashed into your mind? These are the important numbers for cube roots. 1, 8, 27, 64, and 125. Those are the 8, 27, 64, and 125. Those are the perfect cubes. So anytime you see cube root, those are the numbers you need. What if somebody gave me a fourth root problem? Then what would be the numbers I need to look for? 16 and 81. These are the fourth powers. Okay? These are the cubes. These are the fourth powers. And what about fifth roots? There's only one. 32, which is 2 to the fifth power. Okay, these are the fifth roots. The fifth powers are 32. The fourth powers are 2 to the fourth, which is 16, and 3 to the fourth, which is 81. And these are the perfect squares, which are the perfect cubes, cubes, which are 8, 27, 64, and 125. Okay? Now, what's the perfect cube that divides into 72? Which of these numbers divides into 72? And you said 8. And what's the other number that's left over? 9. So the answer to the problem would be the cube root of 8 is 2. And then the cube root of 9, which is, we'll just leave it the cube root of 9. Right, can't simplify that, so we'll just leave it the cube root of 9. All right? Any questions on that? All right, now, suppose the problem gets much more complicated. Then you always want to take 2 steps to do the problem. I call this the radical 2-step. The radical 2-step is where the first step we sort, and the second step we square root, or we cube root, or we fourth root, or whatever it is. But we don't do the roots in the first step. Make the first step always a sorting process. Now, as an example of that, let me take number 36. Number 36 on page 85. Number 36, it says, the square root of 75, x to the fourth, y to the seventh. What I'd like to do is split this into 2 separate square roots. A square root times a square root. And take all the perfect squares and put them up front. What would be the perfect square that's a factor of 75?
25.
25, all right? So that goes up front. What's the leftover number? 3. And then x to the fourth. Now, is x to the fourth a perfect square? Yes, it is. But I don't want to do the square root yet. You see, the first step is just sorting things out. Don't make the mistake of taking the square root of x to the fourth before you're ready to. So I'm going to just put it down as x to the fourth. Now, y to the seventh is not a perfect square, is it? So let's break it down. Back off from y to the seventh into y to the what? Sixth? And what's left over? Y. And that would give you y to the seventh altogether. Now you see what we've done? We've sorted out all the perfect squares into the first radical. Anytime you can get it sorted out and get that first step right, you can finish it. This should be unanimous. The answer that you get after you get to this point, if you can get it sorted out, you should have a clear shot at the answer. Can everybody in here do the square root of this thing, which would be what? 5 x squared, y cubed, and then this we'll just leave it, the square root of 3y. The square root of 3y. Okay? Any question on that? Okay? Now, when you get to a more complicated problem, like number 40, we've got a fourth root. It's the same idea. Sort, and then do the radical. Do the root. But make your first step to do the sorting. Number 40, it says the fourth root of 80, x to the 100th, y to the 49th. Oops, 49th. And my first step is to break it down into two separate fourth roots. A fourth root times a fourth root. Now, when it says fourth root, a lot of people panic and say, fourth root, oh, that's hard. What we're looking for is a perfect fourth power. How many are there to look for? Only two. The 16 or the 81. It's got to be either 16 or 81. Take a guess. It's not 81, is it? It's got to be 16. So put the 16 in the first radical, and then what would be the leftover factor? And how would you get that with a calculator if you wanted to use your calculator to do this? Take the 80 and divide by 16, and it comes out 5, doesn't it? Right, 5. So 5 is the leftover factor. Now how about x to the 100th? What we have to do, we have to be able to divide 4 into 100, don't we? You divide exponents. When you're dealing with exponents, you divide the exponents. So what would I put here? X to the... Now don't do it yet. Remember, that's the mistake a lot of people make. They get it's so enticing. You want to go ahead and do that. X to the 100th, divide by 4, but we're just sorting it out. So I'm just asking, what is a perfect fourth power? And the whole thing is, isn't it? So we'll put x to the 100th there, and y to the what? 48. I didn't leave much room, sorry about that. And then what's the leftover? We got a y left over? Y. Okay, now can everybody in here take the fourth root of all of this? Now we're ready to do the fourth root. Fourth root of 16 would be? 2. And then x, what do we do to the x? 25. And then we do the y, take the 48, divide by 4 is 12. And then the fourth root of 5y. Is that right?
Yep. No, because you've got a square root. Now you have to put 4.
But I meant fourth root. I meant fourth root. What if I don't put fourth root? What does that say, the way I've written it there? Square root. And it's wrong, isn't it? So it's got to be a fourth root. Don't forget the little 4 in the index of the radical. Okay? All right, now, beginning on page 86, we have some operations with radicals, like combining like radicals. All right, let me go back and do a couple of real easy radical problems where we combine like radicals. For example,